So now we will use the substitution method to find the solution for these two equations. To begin with, you want to take one of the equations and solve for a variable. So sometimes I look at both equations and I try to see which one would be the easiest to solve for. Sometimes neither one of them are easier. So in this case, the bottom one, x minus 2y is equal to negative 3, seems to be a little easier. So let's take that. X minus 2y is equal to negative 3. So I need to get x on one side and everything else on the other. So to do that, all I have to do is take negative 2y and add it to both sides. And I'm doing that because x is being subtracted by 2y, so I need to do the opposite. And the opposite of subtraction is addition. That cancels it out. So we have x is equal to 2y minus 3. So now we have x by itself. So I'm going to take this equation, and I've solved for x, so I'm going to take the opposite equation, and anywhere there's an x, I'm going to put what we just found x to be equal to. So the opposite equation is the top one. 5x minus 4y is equal to 9. And anywhere there's x, like I said, we will put in the value that we found. So 5 times 2y minus 3 is equal to, subtract 4y is equal to 9. So we have 5 times 2 is 10y minus, so now we're distributing. So 5 times negative 3 is negative 15. And then we still have this 4y over here, so we'll just add that to the equation is equal to 9. So we want to add like terms. So 10y minus 4y is going to give us 6y minus 15 is equal to 9. So we're trying to get y by itself. So y is being subtracted by 15, so we want to do the opposite. So we want to add 15 plus 15. So we have 6y is equal to 24. We want to get y by itself. It is being multiplied by 6, so we want to divide by 6. Whatever you do to one side, do to the other. So we have y is equal to 24 divided by 6, which is 4. So now we have a number for y. We're going to take this number that we found for y and plug it back into the value that we found for x. Because as you can see, it wasn't completely in its lowest form because we still had that y. So now that we know y, the numeral value for y, we can plug it back into this equation and get the same thing for x. So we have the equation of x is equal to 2y minus 3. So anywhere there is a y, we plug that in. So x is equal to 2 times y, and now we know that y is 4, minus 3. 4 times 2 is 8, minus 3. So we have x is equal to 5. So now we know the coordinates. X is equal to 5, y is equal to 4. So the solution set for this system is 5, 4. Now you can always take these values and plug them back in to each equation. So again, our first equation was 5x minus 4y is equal to 9. So I'll put this up here so we can still see. So we know that x is 5 and y is 4. So anywhere there's an x, we want to put 5. So 5 times 5 minus 4 times 4. So 5 times 5 is 25. Minus 4 times 4 is 16. It's supposed to be equal to 9. 25 minus 16 is 9. So we know that that's correct. We also want to do the other equation, which was x minus 2y is equal to negative 3. Again, we have x is equal to 5 here, minus 2 times y, which is equal to 4, is supposed to be equal to negative 3. So 5 minus 2 times 4, which is 8. So 5 minus 8 is supposed to be equal to negative 3. And 5 minus 8 is equal to negative 3. So we know that our solution is correct.